Okay, good morning everyone. I'm Geoff Higginbottom. I'm an OpenStack architect at Rackspace, and I'm here today to basically give you some insights in how Rackspace do OpenStack private cloud. So a bit of background about Rackspace themselves. We're an IT services company, got a global presence, and we've got a large portfolio of both traditional and cloud-based products. We recently announced that we've going to intend to acquire DataPipe. So when we do acquire DataPipe, assuming that acquisition goes through, the numbers you see here will obviously change quite significantly as we're going to transform, basically becoming the world's largest sort of private cloud player and largest managed hosting service provider. So interesting times ahead. Currently we have 12 data centers around the globe, and we see with the acquisition that's going to grow significantly, enabling us to get into more markets and do private cloud in different locations. So we've continued evolved as an organization, starting doing basic hosting to begin with, and as the market has changed. As the market changed, we've evolved. Is this my laptop or the... All right, cool. I mean, the biggest keynote there really is the fact that, we founded OpenStack along with NASA, and we now provide fanatical support on all the different public cloud offerings. And of course, with our DataPipe acquisition, you're going to see Alibaba Cloud on that slide as well at some point in the hopefully near future. The key point here is that Rackspace evolve over time, and we're constantly changing as the market changes. So why private cloud? Because that's really what I'm talking about, is why using OpenStack for private cloud. Many reasons. From the security perspective, you may have applications and data that are commercially sensitive, you can't place on public clouds. There might be financial, medical, etc. We see a lot of data sovereignty issues where the organizations have legal rules within their organization or within the country. The data can't leave their geo, and public cloud isn't available where they are, so they have to go the private cloud route. It might be for the performance reasons. So you've got very high-intensity workloads that require specific hardware that aren't available in public cloud space. So using private cloud, you can deploy the hardware that meets the requirements of those applications. It can sometimes be purely cost-based. Even looking at the Amazon 3-year pricing models, private cloud can be 20 to 30% cheaper for long-running workloads. Yes, for short test and dev environments, the per second billing you can now get is cost effective, but if you've got long-running workloads, private cloud is nearly always cheaper than a public cloud solution. Yes, that depends on scale, but it is possible. Now, it might be you've got existing hardware in your DC you need to leverage. It might be dedicated security hardware you want to put in front of your workloads, or just existing hardware that you were running, say, VMware on, and you want to reutilize for your new public cloud offering, private cloud offering. So, reusing that investment you've already made to make your cloud cost effective. And also, if you've got legacy workloads you want to migrate into a cloud-based platform, having the private cloud in the same data center as those existing workloads can make that a lot easier process, being able to connect to the same back-end databases, but moving the front end into a cloud-type application platform. So there's many reasons why you might go private cloud. You obviously the only people who can make that decision. We see lots of different customers coming to us with many different types of workloads and reasons for moving to private cloud. A lot of them are actually coming from public cloud. So you decided, yes, you need to go private cloud. So really the question is, why OpenStack? Now, okay, the audience is probably a bit biased here, being our OpenStack days, but there may be some people here who are still thinking of going to OpenStack over something else. So why go OpenStack? Well, some research by Suzy showed that 80% of IT companies in the UK were looking to either adopt OpenStack or were actively adopting OpenStack. So, the market out there is saying, we are moving to OpenStack. A quote from last year's summit in Austin was John Gates, our own CTO, was basically saying that within the next 3 years, he reckons 100% of Fortune 100 companies will be using OpenStack. We heard this morning about half of them are currently using it. It's probably slightly higher than that today, but we see that all the big Fortune companies are moving on to OpenStack, amongst other public cloud offerings, but OpenStack is definitely a large part of their portfolio. And Forrester, who have been a vocal critic of OpenStack in its early days, are now basically saying that OpenStack is ready for business. They are constantly assessing it, and they can see that it's now mature enough. It's got all the features that you need in enterprise and production scale. So all the sort of the flags are out there to say that companies are adopting it, the big companies are adopting it, and small. The analysts are saying it's ready to go. It's got to that level of maturity that it's the right platform to move forward. So to help you understand how OpenStack or how Rackspace deploy OpenStack, I'm going to share a brief summary of our sort of methodologies for designing and implementing an OpenStack private cloud. So initial phase is that we'll have some discussions with the end users to understand what their requirements are, what their sizing might look like, and produce a basic high-level design that we can use to go forward. And part of my job there is really to also try to rule out that OpenStack is the right solution for them. Because not every workload is suitable for private cloud and OpenStack, I might steer some of those deals onto an AWS-type platform. So, be quite strict here in that ensure that the projects you're thinking of bringing on board to an OpenStack private cloud are suitable. Because if you don't, you're not going to fail. You're not going to succeed, you will fail. So, assuming we get through that first hurdle and we agree that it's the right platform to move forward, then we go on to sort of a more detailed assessment phase, where we'll go in again, looking in more detail at what those requirements are, looking at the design in more detail and the sizing, and start to produce a cost model to see how much is it actually going to cost to move this workload onto the cloud, and again, is it cost effective? At this point, we're hopefully doing things face-to-face, but again, we're just moving the deal forward and helping understand what you're trying to achieve and whether OpenStack's the right platform to use. Assuming we get through that phase, we then go into the more detailed design element. So this could be a simple afternoon session, or it could be a 2 to 3 day design workshop, where we really get into the details of what the requirements are, what you're trying to achieve, and how the design is starting to evolve. And really the key for success here is get many people from your organization involved, whether it's the network teams and the support teams for the storage, the compute layers, the product managers, the software developers. They all need to be involved in this process in some form or other to ensure that what we're working towards, the end goal, is a successful cloud that you can use as an organization. I've been involved in deals in the past, pre-Rackspace, where we didn't have that involvement and it wasn't very successful. And I've also run deals where we've got quite large-scale involvement. We've had 25 people in the room for 4 days. It seems expensive, it can be, but it's that level of commitment from the whole organization that is really key to success in making sure what you're deploying is going to sort of fulfill the requirements of the organization. Once we've gone through the design phase, which might take a few iterations of back and forth and agreeing how things evolve, often the requirements evolve during that phase, we then get into the implementation phase. So this is where we then go to actually do a full QC of the hardware that's been deployed. Because just to highlight that within Rackspace, we deploy private clouds into our own DCs, but we also deploy them into your DCs, or even a third-party DC with your hardware or hardware we can provide. So there's many different combinations of where the cloud could be deployed. It's still private because it's single tenant, but it doesn't have to be in a particular DC. It could even be across multiple DCs. But once we've got to the point where we've got the hardware in place, we do quite a lot of checks to make sure it's configured correctly. There's a big reliance on the underlying networking and how things have been configured before we even start installing OpenStack itself. But we get through that phase, we get OpenStack installed, and then we do, again, a large raft of deployment tests to make sure that what we've installed actually works before handing it over for your own QC and testing. So all of these processes are semi-automated. Part of it is we've got OpenStack playbooks, we've got Ansible, and also we've got our own runbooks that describe how we do things on our own experience. And it comes down to basically having done this for many years, we've worked out how to do it in a way that actually is successful. When it comes to which version of OpenStack do you use, there are many choices out there. We as an organization have tried different repos in the past, but are now actually settled on what we would call our own OpenStack version, but we also use the Red Hat version as well. So just to reiterate on that, when we say we've got our own OpenStack version, what we actually mean is that we use the upstream code to build OpenStack from pure open source. So when we hand it over to you, there's nothing that belongs to Rackspace within that code. It's just pure 100% OpenStack from the upstream repos. And we use the OpenStack Ansible project to make that happen. We also recognize that some organizations need things like the Red Hat packaging instead. So we also deploy the Red Hat version of OpenStack to fulfill certain requirements for Red Hat customers. Now, as regards to tooling we use, I mentioned we use OpenStack Ansible. That was actually a project Rackspace started a few years ago, because previously we tried using Ceph and Chef and other, Ceph, not Ceph, other tooling, and it worked for us in certain locations, but then we hit problems. So we developed our own tooling based on Ansible and basically eventually launched and made open source the OpenStack Ansible project that we now use internally for all our OpenStack deployments. It's a great set of tooling because it can also be used for the ongoing maintenance and upgrading as well. Obviously, if we're using the Red Hat version, then that's based on the the Red Hat Director, which uses a OOO as its sort of tooling underneath. The key thing is the tooling that we use needs to be good for the ongoing management and upgrades, not just day one deployments. And that's quite an important point that some people fall foul of, is they get it installed, but then can't do the ongoing management and upgrade. So here's the mission statement for OpenStack. We had a slightly different version of it this morning displayed. This might be slightly out of date. And I think we're about 90% there. The key area we're failing with in OpenStack, I think everyone would agree with, is simple to implement, isn't really true case. Yes, there are tooling out there that I've got OpenStack on my laptop. It's a 3-line installation that gets me a test environment using, again, OpenStack Ansible. That's really easy, but that's not a production deployment. Getting it out at scale where you can use it across a realistic infrastructure is still relatively difficult to do. And again, mentioned this morning in the keynote, complexity is still a barrier to adoption. It's a shame. It's a complex environment, and I don't see it getting any easier. The reason being is that the projects and the services around OpenStack are ever growing, and the actual combination of deployments you could come up with is literally infinite possibilities. CIO Magazine reported that half the people who tried deploying OpenStack have failed. And that's where people like Rackspace and other providers really come into their own. They've got the experience on how to deploy it for you and how to make it successful. So in order to do that, Rackspace are quite strict on which projects we allow you to deploy in your deployment, because you really need to deploy projects which are mature, stable, and production ready. Now, we've got the 6 core projects, which any deployment should really consist of. I say, okay, Swift is optional, but the remaining 5 really are the core ones, where you've got the compute, networking, storage, etc. For anyone who doesn't understand the figures, adoption is a percentage of production deployments running the project based on the latest survey that was mentioned this morning. Maturity comes from looking at 7 distinct tags that indicate stability and sustainability. So the current criteria includes whether or not the project is install guide, whether it's supported by 7 more SDKs, is the adoption percentage greater than 75%, whether it's got corporate diversity, and are there stable branches. So it's a measure of how mature these different projects are. And age, very simply, is how long the project's been around. Now, in addition to those sort of 6 core projects, there are many other projects available and services that are part of that ecosystem. It's a big list. As you can see, there's lots to choose from. And the question is, how do you choose which ones to use? And the challenge here is choosing ones which are mature that you can use in production. And the knock-on effect is if you don't use them, they're never going to be classed as mature because they're not in production. So it's a bit of a chicken and egg scenario here. But in most of our deployments, what we basically focus on is the 6 core. Then we also include Horizon, Heat, and Ironic as the ones that we see as being the most mature. Now, we're constantly monitoring the other projects, and we've got a number of these coming online in the next few months. But we're quite selective, and if you come to us and say, I want Ceilometer, we'll say no. It's not stable, it's not ready for use in production. And this is based on our experience of supporting many, many clouds over the years. I'm sure you've seen our marketing where we've got over 1 billion hours of supporting OpenStack physical servers. So we've been around a little bit, we've done this for a while. We base this on our experience of where we've seen problems. We've tried projects in the past, we've included them, had lots of problems, so we've pulled them from our roadmap going forward. The catch-22 is, you need to try using the projects in your test dev environments to make sure for you they work. And it might be that ones we classify as not ready for us could be ready for you. So this is just our sort of opinionated view. You can obviously work out for yourselves which ones will work for you. You may notice that Magnum's not on that list currently, but we actually are in the process of launching a managed Kubernetes offering, not necessarily based on Magnum, but using our public cloud experience of using containers in public cloud to provide public clouds, like private cloud containerization within OpenStack. And that will also come with Octavia as well to provide load balancing as a service. So things that aren't on the list today, in 6 months certainly will be. It's an ever-changing landscape, and it's a case of constantly assessing each project, how mature it is, how stable it is, how you can support it before launching it into production. So we've chosen the deployment, whether it's Red Hat or our version of OpenStack, and we've chosen which projects we want to deploy. We now need a platform to deploy them onto. So again, we've developed over the years different architectures. This reference architecture has been around for about 3 or 4 years now, I believe. And it's a, again, tried and tested solution that works for a 3 compute node solution to a 3,000 compute node solution. And we've got varying scales of customers using this. So networking is a sort of starting point. Everything has to be HA. We default to 10 gig networking. We have got old deployments running 1 gig, but with the advance of things like Ceph and Swift, we find 10 gig is a better platform to use, and it really should be the default go-to networking today, with 40 gig becoming more common as well. Key points here are everything should be HA, and we stipulate for our load balancing and firewall layer, they ideally should be physical devices. We will accept appliances, but if they are an appliance or software such as HA proxy, they need to be running on physically separate hardware. So, for example, we don't support the load balancers running on the control plane. I mean, HA proxy software you could do. We tried it. It doesn't work, at least not at scale. So we stipulate quite strictly that the load balancing and the firewalls need to be on their own separate physical hardware and certainly not anywhere near the control plane themselves. For the control plane, we have 3 control nodes. These are running, if we use the Rackspace version, then we're using OpenStack Ansible, uses the containerization of all the services. So all of those are different APIs are installed in their own containers, ×3 on the 3 controllers, and that ensures that we can do easy upgrades and migrations. And that's part of the containerization element of the service layer. It really does simplify the upgrade process using OpenStack Ansible. And then we have the 4th node there, which is an elk stack, doing centralized logging of all those different control planes. In the Red Hat model, I'm not showing the Red Hat diagram here, but the Red Hat model is very similar, 3 controllers, but that logging node is replaced by the director, which provides all the installation services using OOO. And in Red Hat, you'd also have optional cloud forms as additional node for cloud management. But that forms our control plane. And then in its simplest form, you need some compute nodes. So those compute nodes could be providing local storage, and then that's effectively all you need to run the basic OpenStack cloud. We rarely see that nowadays, to be honest, though, because that's a very simplistic sort of test dev environment. What you really need is some additional services. So our go-to storage platform now for backing Cinder really is Ceph. Ceph's a great cloud platform. It's something that is scalable storage. It uses commodity hardware. It provides back-end storage for both Glance and Cinder. And if you've got it in place, you can also now provide it for object storage as well. So it's a really sort of a one-box-ticks-all solution, albeit you need 5 boxes. If you don't use Ceph, you can use things like VNC or NetApp devices to provide that back-end Cinder storage. You can also, for test dev environments, you could use a Cinder storage device. But again, we don't recommend that in a production environment. But we have got small deployments running it for test dev type solutions. And then, of course, we've got the Ironic nodes, soon to be Kubernetes nodes, and then the Swift nodes for object storage, the more traditional back-end there. So this platform, as I said, scales across very small deployments to very large deployments. It's tried and tested. We know it works. And it's around the globe currently in hundreds of different deployments. One key thing to remember is that if you are deploying OpenStack, Glance is an important component and it needs a back-end storage architecture. If you've got Swift or Ceph, they're great platforms for the Glance back-end. If you haven't, then you need some other storage to provide the Glance storage. We often see NFS being used as a back-end in a customer's DC, just to ensure it's HA. If it's our own data centers, we can use our cloud forms, public cloud architecture to provide that same type of architecture. So just don't forget about Glance when you come to storage. Monitoring is obviously an essential part of any cloud architecture. We developed our own in-house bespoke monitoring platform we call Monitoring as a Service, but it's built on many common OpenStack to open source technologies that you're familiar with. Basically, we continually monitor the hardware, the OpenStack services, and supporting MariaDB, message queuing services, etc., to ensure that the cloud is operating normally and it's performing as you would expect. We also provide AppFormix, which is really an answer from ourselves to Salamator not being something you can use today. And AppFormix provides the end user a way of monitoring their platform, their workloads, and it also allows them some level of sort of capacity planning, so you can see when their capacity may be running down on compute or storage capacity, so that as they're growing their workloads, they can start to talk to us about actually expanding the physical layer, etc. Upgrades traditionally have been a challenge. OpenStack release a new version every 6 months or thereabouts. And those new releases aren't just about new features, so you don't run for the latest features, but you need bug fixes, security patches, etc. So you do need to be moving to these new features, new releases, at least every 12 months. Ideally, stay 1 or 2 releases within the current release. The problem is, though, that upgrades can be tricky. It's not a simple apt-get update type command. It's a complex procedure to upgrade the whole environment. And again, this is where using the right tooling to begin with is really important to help the upgrade process. For ourselves, because we use OpenStack Ansible, it actually makes the upgrade quite simple. We're down to now probably only a few minutes of downtime for any typical upgrade. We do have a maintenance window, so we still take the cloud effectively offline for changes, but workloads continue to function. And it's really anything around the Neutron layer that might need a reboot of Neutron nodes that causes a brief outage. But typically, we might have a 6-hour maintenance window, but the downtime could be measured in minutes. So we've got upgrades down to be pretty good, but there's a reason we've achieved that, again, using the OpenStack Ansible tooling to deploy the cloud and do the upgrades, and also the process we follow for doing it. So we've got very strict playbooks that our support engineers follow to do initial testing to make sure that the cloud is in the right state for the upgrades themselves. So assuming that in testing is successful, we then actually go on to the upgrade itself, again using Ansible tooling to help us with that process and following playbooks to ensure that we go through a prescribed procedure that we've tested many times internally before we do an upgrade from version A to version B. Once that upgrade has been finished, we then do, again, lots of testing post-upgrade to ensure that the cloud is back online and operating as you would expect before giving it back to you, the user, so you can start using it. Now, upgrades from older versions. So the accepted wisdom is that you upgrade from version 1 to 2 to 3 to 4 to 5 sequentially, and you can't skip a version. And unfortunately, we have got a number of customers who are still on Kilo. Older versions because they haven't chosen to upgrade for various reasons. And we're now going through a big process of getting everyone up to the newer versions. Newton is actually our current latest version, and we're spending a lot of time getting customers onto that version. So in the old days, you'd have to have upgraded them from Kilo all the way through to Newton, which would take lots of maintenance windows, lots of outages, and be basically a right pain in the arse. However, we've been working hard to develop a fast-track upgrade process where we can now upgrade people straight from Kilo to Newton in one jump. So one maintenance window, one upgrade process, and a big leap forward in the sort of the versions and security patches, etc. That's taken a lot of work, and that's something we've done to ensure that our customers are a good foundation going forward before we start moving on to the latest versions. Now, maintenance windows are never great, and it's always causes some problems. So what we're also doing is sort of redefining how we do upgrades. So in the future, we won't be talking about upgrading to version X, and what version are we currently on. You'll simply be on OpenStack. The latest version, running latest APIs, and we're going to achieve that by going to a CI/CD deployment process where we'll be constantly upgrading different components in the background while you're using it. You'll never know. You'll just operate the cloud, you'll use it, and it's there, it works. In the background, we're constantly testing and replacing different components, pulling out containers, putting new containers in, new versions, etc. That's a goal. We're getting there. We're not quite there yet, but hopefully within the next 12 months or so, that'll be a reality. So to summarize, only deploy mature projects in your production environments. Yes, test ones that are not yet mature and try to use them in test dev environments so they can become mature and feed back to those projects to report back bugs and issues, etc. Ensure the hardware platform you're running on is fit for purpose. It's HA, you've got the right underlying architecture, networking, storage, etc. Monitor. You need to monitor the platform all of the time. Things do go wrong. Monitor it, the hardware layer, the OpenStack layer, supporting services, and the actual VMs themselves to make sure things are functioning. And if you can, move to a continual sort of upgrade process where you've got minimum to zero downtime. That's how we do things at Rackspace. That's what's helped us become the biggest, I think, cloud provider in this space, and why we've got over 1 billion hours of experience doing this. That's our experience. Any questions? That means I did a really good job telling you everything. So that list is very long. I actually couldn't tell off the top of my head. Come to our stand outside. We can try and give you a bit more intel. I've got some colleagues who can better answer them myself. But we do use purely open source tools that we've developed into our own sort of monitoring service platform. But it's all the traditional sort of tooling you'll be familiar with. So you had a question here. So the question is OpenStack not suitable for all applications? Which ones may not be? So the telco space is an emerging market in the OpenStack world because a lot of the things they do require additional, again, it was mentioned this morning, higher level throughputs than what we can currently achieve. We're not a big telco player currently, so that where there's like the real-time computing could be an issue. It could just be that it's the old traditional workloads that require infrastructure HA. So we, like most people, provide the KVM hypervisor for the compute layer, which doesn't really provide infrastructure type HA auto failover. So VMware might be a better platform for those old traditional workloads. Whereas if you've got the new, more cloudy type workloads where the application provides the infrastructure, sorry, application layer provides the high availability, they're the ones you should really be putting onto an OpenStack private cloud. So the more modern workloads that are built for a cloud type application, not the ones that rely on infrastructure HA.
Just to get that right, you said if you have traditional tech-like workloads, you would opt for VMware, so there is no real way of having them run KVM?
No, not necessarily. They're the ones that aren't optimal. So if you go for an architecture where you've got the KVM hypervisor but using Ceph as a back-end Cinder storage, you use boot from volume, which means that all of the infrastructure and the data is on Ceph. Yeah. If the hypervisor dies, OpenStack won't automatically restart that VM, but so long as you've got the correct monitoring in place, you can detect that that VM's gone down, and you can then reboot the VM on a separate compute node. So it can provide infrastructure HA. It's not what it's been designed to do out the box. So you can achieve that same level of HA, but it's not the optimal type workload. VMware might be able to do things like that more effectively. Okay. So, it's a cloud application platform. Use it for cloud workloads, ideally.
And how do you do it if you've got big workloads? Like if a company wants to move to cloud-like workloads, but they have some patch, they have the Exchange server or their, I don't know.
We actually have quite a number of deployments where they're running traditional Oracle, say, DB physical architectures, and we can easily deploy OpenStack side by side with traditional physical hardware. That's where that point about deploying it into your own DC to interact with existing hardware is a common reason for go private cloud versus public, so you can help with that migration. So those applications can still connect into the old architecture they were using while you redesign the front ends to be more cloudy and move the databases onto, say, a cloud DB type layer. Anyone else? Right, thank you very much.